Hello and welcome to Physical Science, Section 1.1. This is the beginning of the flipped version of the Physical Science class. Good evening or good morning to those who have not done their homework and are watching it at the last minute. But I'm going to go over Section 1.1 in your science book. The fabulous thing about this is that if you miss something in a note, you may stop, pause, rewind, replay. So this is a perfect way to get used to taking notes in your lecture series. All right, so let's start off with section 1.1. What do scientists do? Scientists do a variety of things. There are also a variety of scientific jobs out there. So let's look at some of the first things they do. First of all, scientists like to answer questions. Okay? Then they like to make a plan to answer that question, which is normally in the form of an experiment, and then they experiment and observe the results. So this is a very shortened version of the scientific method, which we will get to in the next section. All right, so let's look at what kind of sciences we have. We're going to basically focus on the natural sciences, okay, and they have a fabulous flow chart in your book. I have put it up here on the board for you to see. So let's start off with biological. All right, so we could start off with botany. Botany is the study of plants. So these are scientists that look at how plants grow, how the chemistry works, photosynthesis. The next one is zoology, which is the study of animals, how animals behave, interact with each other. Then there is ecology, which is the study of how nature interacts with each other, living and non-living things. How important is a lake system to certain types of fish as far as water chemistry, what kind of rocks are in the water, depth. So that was some of the things you would look at in ecology. Okay, now I'm going to move on to the physical sciences. This class is physical science. So what we're looking in physical science is we're looking at physics, which is how things work in the world, and also chemistry is how matter interacts with each other. So we're looking at both these aspects as far as how does our physical world work around us. Okay, next is earth science. For those of you that were at Hammond, you have studied some of this before. We have geology, which is the study of rocks. We have meteorology, which is the study of the weather and the weather patterns. Astronomy, don't get it mixed up with astrology. Astronomy is actually the study of the stars in the universe. All right, and of course within these there are many other branches that branch out. In fact, you might not really think about this, but even a car mechanic is technically a scientist. All right, so let's look at what scientists use. They use technology, okay? This is used for practical purposes to solve problems. We also break that down also into two separate scientific laws and scientific theory that you can use technology in. Okay, so let's look at a scientific law. A scientific law is a process tested many times. Okay, Newton's 3 laws. Okay, law of motion, gravity. Okay, we can test it. I mean, okay, so that's a law. Now, a law does not tell us how the process works. Okay, so when we're looking at a scientific law, we're looking at a process that is just tested many times, and we can also use it to predict what's going to happen in a system. Okay, so I have a system. It is a clipboard in my hands. Okay, so if I'm looking at gravity, and I can predict that if I let go of this clipboard, that gravity is going to work. Okay, because gravity on Earth is about 9.8 meters per second squared of acceleration, pulling towards the center of the Earth. All right, so I can test it, and it worked. Okay, so these are laws. Now, scientific theory will explain how a process takes place. So it explains why it's happening. So if I were to say this is a scientific theory, it would explain that there is a force pulling towards the center of the Earth called gravity that works at 9.8 meters per second squared acceleration. That force, when nothing is interacting with this clipboard, is going to actually pull this clipboard down towards the center of the Earth. So it's actually more of an explanation of what's going on. Okay, so those are your scientific law and scientific theory. Now we do use technology in this to try to prove these. Okay, so let's review. We have talked about what a scientist actually does. We are talking about the natural sciences, some fields within the natural sciences, what technology is, and how we use scientific laws and scientific theories to explain what's going on in the world around us. Okay, so that brings us to the last part of your section. And I'm going to re-angle the camera so that we can go look at some explanations of models. Okay, so models. Models are used when systems are too large or too small to work with. Okay, so we could have a number of types of models. We could have pictures, we could have three-dimensional models. So I'm going to look at a couple examples. These are actually pictures and kind of graphs, especially down in here using pictures, that show systems. Okay, this is the Earth. This is how the atmosphere interacts with water. Now, on the other hand, they could be very complex, but they could be very easy. Here is a subtract the fish model, mathematical model used for little children. 6 minus 4 is equal to, and there's an empty space. So models can go from very complex to very simple. They could be three-dimensional. We could use this as a model of a truck. Obviously, a truck is too large to bring in here, so if I wanted a little model of a dump truck, I could use this. Or, for something very tiny, I could use this for a model of H2O, okay, for a water molecule. Obviously, water molecules are too tiny for us to see individually, so we would use a model. Well, I thank you for joining me in doing this very first lecture series, and we will do more of these throughout the year, so I hope you have used your Cornell note-taking method to take good notes and are prepared for class. Thank you.